Good day students. Myself Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. I am dealing with the fifth paper of MSc Final Physics, that is Solid State Physics. In my previous lectures, we have discussed about magnetic properties of materials. Now, on the basis of my lecture series, today we will discuss some questions on magnetization. The questions are in the form of MCQ and I am providing you the answers with their explanation. The first question is, which of the materials have a permanent magnetic moment? The options are ferromagnetic, ferrimagnetic, diamagnetic and paramagnetic. Among these options, the correct one is ferromagnetic material. Why the ferromagnetic material is the correct one? I am going to give you the explanation behind this answer. The ferromagnetic materials have a large number of unequal electrons spins. Hence, they will have magnetic moment, and this property is the unusual property that occur in substances. These ferromagnetism is the basic mechanism by which materials like iron, they form permanent magnet, or we can say that they are attracted to magnets. Permanent magnets, they are either ferromagnetic, that means example, I am giving you example of these ferromagnetic materials. They can be iron, cobalt, nickel, and some of the alloys are also ferromagnetic in nature, which form permanent magnet. Now, the other question which we are going to discuss is, which of the following materials exhibit spontaneous magnetization? Paramagnetic, ferrimagnetic, diamagnetic or ferromagnetic. Among these, we have to discuss the spontaneous magnetization in a material. Spontaneous magnetization is the appearance of ordered spin state at zero applied magnetic field. Among these materials, it exhibits in ferromagnetic material. That means these materials, they show magnetization even in the absence of any external applied field. So the correct answer among the options given is D, that is ferromagnetic materials. They exhibit spontaneous magnetization. The third question which we are going to discuss is, we are given a piece of ferric oxide which have a magnetic field intensity 10 raised to power 6 ampere per meter, and the susceptibility given to us is 1.5 into 10 raised to power minus 3. We have to determine the magnetization of the material. We know that susceptibility chi is equal to I upon H. Here H is the magnetic field intensity and I is the magnetization. So the formula which we are going to use is I equal to susceptibility into H. Now putting the values, the susceptibility is 1.5 into 10 raised to power minus 3 and H is 10 raised to power 6. So using these, we get the magnetization of the material to be 1500 and the unit of magnetization is ampere per meter. So the correct solution among the MCQs which are given, options which are given is D. Now we are going to discuss the next problem. In the next problem, we are given that the material is ferromagnetic. Then we have to determine what should be the value of chi. That means what should be the value of susceptibility. We know that a material is ferromagnetic. So, for a ferromagnetic material, there is a spontaneous magnetization in it. So, the susceptibility of this material should be large and it is positive. That means the option which is correct is C. The chi must be large and positive. If we compare it with a diamagnetic material, then for a diamagnetic material, chi must be negative, and for a paramagnetic material, it must be small and positive. So, the given problem, which is of a ferromagnetic material, we have to determine the value of chi, which should be large and positive. So, moving over to the next problem. The next problem is we have to find that when we increase the temperature, that means at a high temperature, ferromagnetic material will behave as the options are dia, para, hard ferro and soft ferro. The correct option among these is paramagnetic material. In order to explain this, we know that the properties of ferromagnetic material, they are dependent on temperature, and when we heat a temperature, it will become a paramagnet, and this transition occur at a particular temperature which is known as transition temperature or Curie temperature. The next problem is we have to find the value of B and we have H to be equal to 0. We have to find the value of B at which H is 0 and we are given a hysteresis curve. In the hysteresis curve, the value of B at H equal to 0 is termed as retentivity or remanence, and it shows the capability of a material to hold the magnetization. Moving over to the next problem. The next problem is we have to find the desired condition for the core of a electromagnet. The core of an electromagnet is made up of a ferromagnetic material, and we know that ferromagnetic materials have high permeability and low retentivity. Because of these properties, we can easily make the core of an electromagnet which is made up of a ferromagnetic material. The next problem is if the number of atoms in domain of a ferromagnetic ion in the form of cube of side of length 1 μm is 8.65 into 10 raised to power 10 atoms and the dipole moment of each iron atom is 9.27 into 10 raised to power minus 24 ampere per meter square. Find the maximum magnetization of the domain. Since the maximum dipole moment can be determined by using the number and the magnetic moment. The number is 8.65 into 10 raised to power 10 and the magnetic moment of each iron is given to us is 9.27 multiplied by 10 raised to power minus 24. So, the maximum magnetization will be 8.65 which is the 8.65 into 10 raised to power 10 multiplied by 9.27 into 10 raised to power minus 24. The magnetization maximum will be, on calculation, it will be simplified to 8 into 10 raised to power minus 13 ampere meter square. And we are given a cube which has a length of 1 micrometer. The volume will be 10 raised to power minus 18 meter cube. Hence, the magnetization, we have already find out the maximum dipole moment. So, from maximum dipole moment, we can find the magnetization. Magnetization has a formula, maximum dipole moment divided by volume, which on simplification gives us, and substituting the values will give us 8 into 10 raised to power 5. The unit is ampere per meter. So, the correct option in this problem is C, that is 8 into 10 raised to power 5 ampere per meter. The next problem is, with an increase in the area of hysteresis curve, we have to find what will be the correct option for the power loss. Since we know that power loss is directly proportional to the area of hysteresis curve, so in the given problem, as we are given that area of hysteresis curve increases, the power loss will also increase. That means the correct option is A. The next problem is, we are given two hysteresis loops of a ferromagnetic material denoted by A and B. We have to find that which material is used to make magnet for transformer core, electric generator and electromagnetic core. We can clearly see from the diagram that area of the curve which is shown in the B is less. So, the correct option will be C. That means we will use the material B for electromagnet and generators, because in this case area is less, that means power loss is very less. Thanks a lot for watching.